Hey guys, it's off1 here, and today we're going to be solving longest increasing subsequence. In this problem, we're given an integer array nums, and they want us to return the length of the longest increasing subsequence. So what does this mean? For this example here, we can see that the output is 4 because the longest increasing sequence is going to be 2, 3, 7, and 101. So let's see. 2, 3, 7, and 101. And as we can see, if we start from 10, the longest subsequence would be just 10 and 18 or 10 and 101, which is only 2. And that's not what we want. Before going any further, I want to say that there is an O of n log n solution, but this solution is not very intuitive and very hard to understand. It involves doing a binary search, but in this video, I'm only going to show you the O of n squared solution that involves dynamic programming. And I'm pretty sure any interviewer would only expect you to be able to produce this solution. Now that we have that out of the way, let's get into our solution. So here I've set up an array nums, and here I have an array that we're going to use to store our values in. And what we're going to store is our longest subsequence up to that index. So for example, for index 0, we're going to have a 1 because that is the longest subsequence. And then for this index here, 1, our longest subsequence would be 2 because 0 and 1 form a subsequence. And then for 0 here, we're going to have 1 again because 0 and 0 do not form a increasing subsequence. And now for 3 here, what's our longest subsequence up to this point? So we know we have 0 and 1 as a subsequence, so 3 would come after that, and at 1 we see that our longest subsequence is 2, so what we want to do is increase that by 1, so our longest subsequence is now 3, and same thing with 2. 0 and 1 are the subsequence before it, and then 2 comes after, so the longest subsequence here would be 3. And then for this 3 now, the longest subsequence would be one of these two. So let's see, it could be 0, 1, and 3, and we know that's not true because 3 and 3 are equal here. Or it could be 0, 1, and 2, and then we add 3 at the end. So that's true. So our longest subsequence up to this point would be 4. So what did we learn here? Well, first we have to realize that to check if a number is currently part of a subsequence, then we have to check if any numbers previous to that are smaller than it. So for example, let's say this is index I, and let's say this is index j. We have to check if nums at j is less than nums at I, then we want to do something here. So before going any further, I want to give this array a name just so we know what to reference it as. I'll just call it result array. And so now, what do we want to do? Well, we want to set our results at our current iteration equal to what? Well, we see that at j here, our max subsequence is 1, and to get to 2, all we have to do is add 1 to this. So we could just do result at j plus 1. And that should update our longest subsequence. However, there's still a problem here. So let's say these two weren't part of our array anymore, and we were trying to solve for 3. Well, we know by looking at this that our longest subsequence would be 0, 1, and 3. But because we're iterating just linearly, then we will see this last. So our result at I would be updated to result at this index plus 1. So this would be read as 2. And that's not true. So how can we fix this? Well, if this was our current iteration and we're iterating through every single number before that to check if it's greater, then what we want to do is keep the greatest result. So really what we want is result at I and the max between all of the previous values that met this condition. So we would have max of result at 0 plus 1, and result at 1 plus 1, and result at 2 plus 1. And the value for this one would be result at index 0 plus 1, which would be 1 plus 1, so 2. And then here it would be 2 plus 1, so 3. And then here it would be 2. So what we want to keep is this value here. And now that we know that, I'll edit the pseudocode a little bit to better reflect that. So what we want to set result of I as is the max between our current result or result at j plus 1. And it should cover all the cases. So let's just move these, and let's say this is j and this is our I still. If we're at j, then that means our result at j plus 1 would be equal to 2. But our result at I from the previous iteration would be 3. So we would still keep a 3 here, and that would be the correct result. So now all we have left is to put in our for loops. So for the j iteration, we want to do for every number up to I, we want to run this if condition and then update our max as needed. And then for the big for loop, for I, we want to do for every number. And that should get us the correct result. Our time complexity for this algorithm is O of n squared because we're using nested for loops here. And for space, we have this result array, and that takes O of n space because that is where we store our longest subsequence length. And now that we have that, let's get into the code. So to start, I'm going to initialize a variable for our nums length. And the reason I'm doing this is because I found that the solution times out pretty easily, so if we can just save any multiple calls, that would help a lot. And now we're going to initialize our result array to have all ones for a length of num. And then from here we want to initialize our base case, so result at 0 is going to be 1 because that would be the max subsequence. And then we also want to have a variable to keep track of our max. And then from here we can just do our for loops. So for I in range of nums length, what we want to do is check every iteration before that and see what the current max subsequence is. So we would have for j in range of I, we check if the number at I is greater than the num at j, then we want to update our max if needed. So the max would be from our current result, or it could be result at j plus 1. And now we check if our max is less than the current result's longest subsequence, then we want to update it to be that. And then at the end here, we can just return our answer, and that should work. So as you can see, this solution is not very good, but if you do the binary search, then you would end up over here. But like I said, this solution is sufficient for this problem. So now we'll go through the code manually. So what I've done here is initialized our nums array that we're going to use, and I've also initialized the answers value. And here's our result array currently. So our result array is currently populated with all ones, and as you can see here, this is the num and the index it corresponds to. And then down here is where we're going to keep track of our iterations. So let's get started. So like I said, we've already initialized our result array and our base case and also our answer. So now we just want to iterate through all of the numbers. So we're going to start at 0, but as you can see, there's no numbers before 0 here. So we're just going to skip that iteration and go to the next one. So now we're at I equals 1. So from I equals 1, we want to iterate just through 0, because that is the only number previous to I, and we want to check, is nums at 1 greater than nums at 0? Well, we can see that that's true because nums at 0 is 0 and nums at 1 is 1. So what we're going to do is check if our current max needs to be updated. So our current result at I is 1, and our result at j would be 1, but result at j plus 1 would be 2. So that is the max, so we're going to update that. And now we check, is our answer less than the result at I? Yes, because answer is 1. And then that's it for that iteration. So now we just go to the next one. So for I equals 2, we want to start at j equal to 0, and we check if nums at I is greater than nums at j, and it's not because 0 and 0 are the same. So now we just skip this iteration and go to the next one. So now we're at I equals 3. So for I equals 3, we want to iterate through all the j's before it and check if nums at I is greater than nums at j. So currently, our nums at 3 is 3, and our nums at j is 0, so it is greater. So now we just want to update our max. So what's greater, our current result or a result at j plus 1? We know that result at j plus 1 would be 2, so that is greater. So what we're going to do is update that. And now we check. Is our max less than our current result? Well, they're equal, so no. It doesn't need to be updated. So now we go to the next j. And now we check again. Is 3 greater than 1? Yes. So we want to update our result to be equal to result at j plus 1, which would be 3. And we can see that this gives us a new max, so we want to update that as well. And now that we have that, we can just go to the next j. So our next j is going to be 2. Is 3 greater than 0? Yes. And what's greater? Our current value or the value at j, which would be 1 plus 1. So 1 plus 1 is 2, and if this is 3 and this is 2, our max is going to be 3, so we don't update it. And now all we do is return the answers, which is 3. And that's correct. That is the length of our longest subsequence. If this video helped you in any way, please leave a like and subscribe. Thanks for watching, and I'll see you in the next video.